Okay, this video is focused on section 10.3 and the Rguroo applications. Plus, I'm going to cover the minimum sample size for proportions, as the formula is different than the minimum sample size for the means. So first up, the State Education Commission wants to estimate the fraction. Fraction is a synonym for proportion. So when you see fraction, it's interchangeable for proportion. Both of them are parts over the whole of 10th grade students that have reading skills at or below the 8th grade level. In an early study, the population proportion was estimated to be 0.21. How large a sample? Now, those are key words in this section. So when you see how large a sample, what they are telling you is that it is an n equals formula, because the sample size, the symbol for sample size is n. And this is actually a problem that we would not be solving in Rguroo completely. There's parts of it that we need Rguroo for, but the overall formula is essentially done out by hand or typed into the calculator. So your keywords are how large a sample. That cues to you, oh, let me get out my minimum sample size formula. Now, I'm not necessarily a fan of the way that the Hawkes textbook writes that formula. I prefer in the way that I displayed in my previous lecture, but shoot. Oh, here we go. So I found the way that I like the formula written on this random site. So I am using this just to share what it looks like. But n is equal to the proportion that's given. Q represents 1 minus p. Okay, so the complement of the proportion. This z-score here is a critical value. We practice finding critical values for confidence intervals in 10.2. I'll show you again how to find that critical value. Big E down here stands for margin of error. That is typically given in the body of the problem. You just have to look for the words, something referencing error or within or between. They're referencing the error margin that you want during your study. You don't want to be so far off. So we're talking about proportions here. So it's some sort of proportion. I don't want to be more than 3% off, 4% off. It's usually around 3%. That's the universal margin of error mark that we typically use. And then this division is squared after. Okay, so back to this problem. I see that my population proportion P is 0.21. So I'm going to write that down, 0.21. And then I'm keep reading. How large a sample would be required in order to estimate the fraction of 10th graders reading at or below an 8th grade level with an 85% confidence level? That's important. That's going to help us find our critical value, that z-score, with an error at most of 0.03. So that's that key wording that tells you that big E, the margin of error, is 0.03. Okay, so let's head over to Rguroo, only so that I can use the calculator, and I need to use it to find that critical value. I'm just going to open up the Desmos calculator, which is really helpful to use because it allows you to produce formulas and just change out the numbers, or copy and paste things without over rounding, and also copy and paste so you don't have copying mistakes, which is very common when we're trying to copy a bunch of digits from our calculator, our handheld calculator. Okay, so let me type in the formula. So the formula was P times 1 minus P multiplied by a fraction where at the top we have our z-score, which is called a critical value specific to the confidence level mentioned, over our margin of error, and this whole thing is squared. So to square this, that's this button here, a squared. This is actually the formula. Notice that Rguroo is telling me, I have no idea what you want me to do with all these letters, and that's okay, because I didn't write this so that it would actually calculate it. I wrote it so that we can take a look at the formula right in front of us. So when you're doing these problems, the two numbers that are always given in these problems, in the Hawkes problem, are P and E. Okay, so remember P for us was the population proportion 0.21. So let's change that out. And both these spots should be the same number. E was that error within margin, which they told us they want it within 0.03. So really the only thing that you need to calculate and find before you find your final answer is your critical value for your confidence level. So this particular problem mentioned 85%. Critical values are always referencing in this chapter anyway for confidence intervals. The confidence level is always a centered middle area. Okay, so that means we're looking at a standard normal curve where the 85% is in the middle, and we're trying to find those z-scores that mark the middle 85%. We've done this in our continuous probability chapter. We found critical values that mark an inner area. So this is not necessarily new, but the wording or the way they're presenting the data is definitely new. So if we come over here to our handy dandy continuous probability calculator that we've used a bit now, we ask ourselves, are we being asked to calculate a probability? Are we trying to find values? We are trying to find critical values, so we definitely need to change the mode of the calculator. All of our critical values for either 10.2 or 10.3 are always using the standard normal curve. We're always going to use z-scores. You never use t-values for minimum sample size problems. And the mean and the standard deviation stay 0 and 1 because, again, we're trying to produce z-scores here. And they always have a mean of 0 and a standard deviation of 1. So for all of the critical values in Chapter 10, you'll be selecting between. Remember that our Rguroo does not automatically assume the area is centered in the middle, and therefore it asks about what is the area in the two tails, the lower tail and the upper tail. And this is because sometimes this between area could be shifted to the left or to the right. As you saw in the continuous probability chapter, we worked with grades A, B, C, and D, and those areas were not always in the center, depended on which grade we were referencing. For these, they're always centered. So let's do a calculation real quick. I'm going to need to bump that up for a second. In order to find the area in the tails when you have a centered 85%, you are going to take the total area under the curve, which is 1, subtract out that area that you know is not in the tails, because you know 85% is in the middle, so it can't possibly be in the lower and upper tails. That leaves me with 15% to play with. But that's the total area in both tails. But I need to split that up so that I know how much exactly is in the lower tail and how much is in the upper tail. And we do that because we know the standard normal curve is symmetric, meaning exactly 50% of the area is in the bottom half and 50% of the area is in the upper half. So if I know the total area that is in the two tails is 0.15, then to find out how much is in the left tail and how much is in the right tail, I just simply divide it by 2. Okay, so this is the area that I need to write in both the upper and lower tails in this probability calculator. I'm going to paste that in. That equates to 15% if I added it back up. And when I hit my eyeball, I get the z-score that marks the left side of the middle 85% and the z-score that marks the right side of the middle 85%. Now, for this particular minimum sample size calculation, you only need either the negative or the positive. It really doesn't matter. And the reason why it doesn't matter is because notice that this critical value will always be squared. So two positive numbers, or a positive number squared is going to be positive, and a negative number squared is also positive. To save yourself some confusion, though, I do highly recommend we stick with the positive version, just makes it simpler. And z-scores are always rounded to 2 decimal places. So I'm going to enter in my critical value of 1.4 and rounding up 4. So over here, replacing my z with 1.44, and I can see that my minimum sample size comes out to be 382.2. Now, the rules for minimum sample sizes are the same as they were last week with the means in 10.2, and that's that you always have to round up. Because at the bare minimum, we need 382 people and 0.23336 of another person. Obviously, we can't ask an arm what their answer is to a survey question, which means that person becomes a whole person, and we round up to 383. Nice. Okay, so those are the problems that you see in 10.3 that ask you how large a sample. All of the other problems are asking you for point estimates and confidence intervals. So let's take a look. Let's try one. Here we go. So an environmentalist wants to find out the fraction or proportion of oil tankers that have spilled each month. First step, suppose we have a sample of 485. Okay. And of these ships, 335 did not have spills. Okay, so we have 335 no spills. They want us to find the proportion of oil tankers that had spills. Now, here's where you have to be very careful. You need to decide whether the category that they want the proportion of, this one is having spills, matches the part that they give you. In this particular case, they do not match. They want the proportion of spills, and they give us the count of no spills. So there is an extra step in this problem than some of the other problems. I'll make sure to cover one where this extra step is not needed. We need to find the part that represents spills. So if we know there's a total of 485 tankers and 335 of them did not spill, then the way to find the amount of ships that did spill would be to simply subtract. So coming over here to my calculator, I'm going to enter my total sample size of 485. If I subtract the tankers that did not spill, then I'm left with the remainder of 150. So 150 represents those who did spill, which is the category that they want in the proportion. Okay. So in order now to find the proportion or estimated proportion, okay, remember that point estimates are the sample proportions, or sample means if we're in the means. So we have to calculate that proportion. All proportions are parts over the whole. The part needs to correlate with the category we are specifying. So my part for spills is 150. We just found that by subtracting. And my whole is 485. So if I come into our Rguroo, again, I'm just using the regular calculator, and I say, okay, my part is 150. 150 represents those tankers that spilled. And I divide by 485, the total number of tankers I sampled. Then I can see that my estimated proportion is 0.309 if I round to 3 decimal places. So 0.309. Okay, so that's how we find our estimated proportion, or our point estimate. The second step in all these questions is then going to ask you using the same data. Okay, so again, my categories are opposite, but I already have the 150 for the spilled category. They're then going to give you a confidence level, and they are going to ask you to calculate a confidence interval. So recall, confidence intervals allow us to be more confident about what's going on in the population. Our point estimate, yeah, we have a point estimate and we can not apply any confidence to that. We can't say how accurate we expect that point estimate to be. But when we create a range of numbers built around a 95% confidence level, then we are able to talk about how confident we are that the population proportion falls within this range of numbers. All right, let's do it. So here in our Rguroo, let's head over to analytics, analysis. Last week we were working under mean inference. This week we are working in the proportion inference. Always one population for this class. Okay, we don't have a data set, so we're going to leave that alone. Come over here. My sample size is 485. The number of successes has to match the category we are focused on. And in this case, that is the tankers that spilled, which was 150. I need to actually click somewhere else for it to calculate. All these gray boxes are got boxes you don't type anything into. Our Rguroo calculates for you. So if I just tap on the name of this calculator, you'll notice that it does a calculation, and it should match what we calculated by dividing 150 by 485, so 0.039. Okay, looks good. Unlike the means calculator was in 2 different tabs, here they kind of have both chapter 10, confidence intervals, and chapter 11, which we'll start next week, test of hypothesis. They have it on the same screen, so just ignore this bottom right box until we start chapter 11. And chapter 10, we focus here on the confidence interval box. Now for proportions, we do not need to choose between a Z or a T. Yay. Every single proportion problem solely uses the Z distribution. So we do need to remember to check this box, but we can ignore these two. And we just have to make sure the confidence level matches what they wanted in the problem. This problem wanted 95, so we're good to go. When we hit our eyeball, it is going to remind us what labels it needs. Factor label is missing. Okay, so we're talking about tankers. You can just put anything, by the way. You can put ABC, gibberish, just type on the keyboard. They just need something there. But if you want it to match the problem, then label it appropriately. So overall, the sample is a bunch of tankers, and my success label are those that spilled. Okay, then I hit my eyeball, and I can see a bunch of data that they give me. So here I have my percentage of tankers in the sample that spilled, about 31%. I also have the complement to that, the percent of tankers that did not spill, 69. Passing a central limit theorem requires our n times p to be greater than or equal to 5 and our n times 1 minus p to be greater than or equal to 5. That is something we learned last chapter. And those are these numbers here. So you just have to double check in order for this to be a valid calculation that both these numbers listed in the report are at least 5. We're way over 5 here. Good to go. That means that this confidence interval is a valid calculation. So I am going to put 0.268 as my lower limit. And my upper limit is 0.350. And essentially, the interpretation would state that I am 95% confident that the population proportion for tankers that spill falls within approximately 27% to 35%. Okay, so I'm saying that if I was to go out into the world and produce 100 different samples of tankers and calculate a p-hat, a sample proportion for each of the 100 samples, 95% of those, 95, not percent, 95, same thing, 95 of those sample proportions will fall within this range, but 5 of those sample proportions are likely to fall outside the range. That's what it means to be 95% confident. Okay, let's try another one where the categories actually do match. Okay, this one, let's see. Nope, these are opposite again. Notice that they give us a count for not defective, but their proportion is focused on defective. So you would have to do the subtraction in this problem as well. Okay, so in this one, we have an automotive manufacturer wants to know the proportion of new car buyers who prefer foreign cars. Suppose we have a sample of 2,954, so that's my sample size. Out of those sampled cars, they tell us that 915 of them preferred foreign, okay? Using the data, estimate the proportion for buyers who prefer foreign. So notice that the proportion category preferring foreign matches the count they give us this time. They're not opposite. So that means we don't have to subtract to find the count. We already have it. And in order to estimate our point estimate, we're going to take our part of 915 and divide it by our whole sample size of 2,954. So if I come over here to my scientific calculator, I'm just simply going to put my part over the whole. So my part is 915. My whole is 2,954. And that gives me a sample proportion very close to my last one. Wow, I almost thought I did this wrong. This was 0.3092 and this one's 0.3097, super close. But because I have to round to 3 decimal places, this 7 makes this 9 round up to a 10, giving me 0.310. Okay, that's my point estimate. Again, I have no idea how confident I am that the actual population proportion is anywhere near 31%. So that's why the next step says, okay, now with 98% confidence, show me a range that we would expect 98% of the proportions to fall within. Okay, so I am gonna head over to Rguroo to my population proportion calculator. Okay, notice I'm still in the report of spilled tankers. In order to open up the calculator again, you could come back to analytics, analysis, and open up a fresh calculator. In fact, many of you may prefer to do that because you don't have to delete things out and be afraid that you don't delete enough out. But if you want to stay within one tab, you can just click your basics button. It opens up the calculator that you use to create this report, but you will have to replace all the numbers. So it's up to you whether you're comfortable with making sure you change everything out and don't leave anything there from the last problem. So 2,954 is my sample size this time. My number of successes was 915. Notice that this proportion has not changed. It won't change until, again, I click over here and then it calculates, and we can see it matches what we calculated in our scientific calculator. This time, this count represents cars, and this one is foreign. And we want 98%. So notice down here where it says confidence level, I had to change the 95 to 98. And because I'm using the same screen that I used in the last problem, my checkbox is already checked. If you are regenerating a new screen, a new population proportion calculator, don't forget to check that box. When I hit my eyeball, I now get my lower limit. I will have to round this up. Okay, this 9 is going to round up to a 10, so there's going to be a 0.290 as my lower limit. My upper limit, let's see, 0.329, and then a 5, also rounding up to a 10, so I get 0.330. And there we go. Again, my conclusion would be that I'm 98% confident that the population proportion for those who prefer foreign cars falls within 0.29 and 0.33, or between 29% and 33% of new car buyers. Hopefully this video was helpful for getting you through the 10.3 homework.